So I should say up front that I really dislike simplify questions because the question is simplify to what purpose, right? Like, why are you trying to simplify this? What are you trying to do with it? And so in a calculus course, this sort of expression comes up all the time, and you simplify it until you can do something called taking a limit of it. So you simplify with this like external purpose in mind, and once you've gotten to a point where you can do this calculus thing, then you stop simplifying. Okay. So what I'm going to do is I'm going to show you what I think the question wants based on what a calculus student would do. So anytime you have square roots like this, the standard calculus thing that they usually want is for you to do what's called multiplying by the conjugate, which just means like there's a minus right there. Just change the minus to a plus and multiply through by that. But of course, if you multiply the top of a fraction by something, you have to multiply the bottom of the fraction through by the same thing. So once you've decided I'm going to multiply the top by the conjugate, then you are forced to then multiply the bottom by the conjugate. So, it looks pretty nasty here, but let's just see where this takes us. So I skipped a step here, but, 1 over root x plus h times itself. That's just 1 over root times root. Right, so the root goes away. And then you have a minus 1 over root x times this, plus a 1 over root x times that. So those disappear. And then you have a minus 1 over root x times itself. And so you're left with a 1 over root x, which is just 1 over x. And then the bottom, I just crammed everything together. Okay, so now on the top here, you have a fraction here. Minus another fraction. So let's just get a common denominator and do the subtraction. So to get a common denominator here, you have to multiply this fraction through by x, this fraction through by x, this fraction through by x plus h. And when you do that and do the subtraction, you get this expression. And the bottom of the fraction I haven't changed. And then x minus x, that goes away. Minus h is a minus h. So that's all that is. And then the h up here cancels with the h right there. So if you actually do the fraction division here, you have a fraction, fraction inside of a fraction, right? Anyway, this h up here will cancel with this one, so that's why there's a 1 here, and there's no h down there. And now at this point, this expression here doesn't really look any nicer than what we started with, right? We started with this, so this right here looks less complicated than this. So again, it's not clear to me what these sorts of problems even want you to do, simply because, like, why bother ending up with this? So I can tell you that in a calculus course, this expression here is a lot nicer than what we started with. But of course, you're not in a calculus course, so it's not, that they can't be asking you to do a calculus thing here. So if you want to take this and do stuff with it, you can. So I did one more step here. You got fractions inside of fractions, so you can cut that out if you want. So I moved the x plus h to the bottom. But then from here, I don't know if they want you to, you can combine these two fractions here, this plus, and then multiply all of this through. And you'll eventually get a 1 divided by something kind of nice looking, I guess. But again, it's not clear. For my calculus students, they would stop right here and then do something calculus-y to this expression, and it would give them a derivative, which is a calculus thing. And the derivative is what they were going for to begin with. So they would have been doing all this algebra here, all of this manipulation here, with the end goal of getting a derivative in mind. But for you, I don't really know what your end goal is. I think maybe since you might take calculus later, they want you to get practice doing this sort of trick, this sort of algebraic trick, so that when you see this sort of thing in a calculus course, you're not confused by it. I don't know. So to answer your question, I don't really know what they want, but this is what I would want my calculus students to do. So anyway, I hope that's helpful.